Hey guys, what's up? A little disclaimer before I get into this video. You're going to see me swipe down several times out of the corner just to make sure that I'm still recording and that my microphone is still on. I've been having some trouble with this video getting it to record. It just randomly stops in the middle. So I've actually taken my AirPods out. I'm trying to do it with that, so we're eliminating that and just see what happens. So we're going to get into the law of sines here. We left off in a weird spot before we left school. We were right in the middle of the graphing chapter. We did sine, cosine, tangent, and cotangent. The only thing we had left was secant and cosecant, which basically you graph the reciprocal of. So you either graph the sine or the cosine graph, and then you would create a system of asymptotes based on where the graph crosses the x-axis, and then you would put some parabolas in at the peaks and valleys. It's not ultra useful, and it's not really real-world related all that much, so it's not worth us wasting our time for right now. The only other thing we needed to do was graph transformations, which involved moving those same trig graphs up, down, left, right. You'd already been doing the vertical and horizontal stretches and compressions, if you remember that from Algebra 2, if you had me, when we talked about mother functions. That is associated with, it's built into the amplitude and the period. So we had already been doing that. So really the graph transformations thing would have been really easy, and you had already been flipping them upside down. So if we get back to school, we may hit it real quick, but it's not too bad if we miss out on it. So also we'd been talking for a while that Chapter 5 was pretty lit. That would have been the next thing that we were getting ready to start. I've decided to go ahead and skip that part right now. And if we get back to school, do it face-to-face. If not, I'll do it through here, and it's not a big deal. We'll just have to work through it. But Chapter 5 and 6 both work together with that kind of stuff. So I've gone ahead and gone to 7. 7 is associated with solving triangles that are not right triangles. So all of the SOHCAHTOA information that we've had for all along is always based on a right triangle. And that's the only thing that it's applied for. Basically, SOHCAHTOA is useless on a non-right triangle. And you're smart enough to realize in the real world not every triangle is right, and you need some other stuff to use. So there's this thing called the law of sines, and the law of sines is useful to us if we're given some certain pieces of information. There are some other things moving forward that are based on other information that we're given. So today, the law of sines, I'm going to write it out for you here. It looks like, whoa, move that. It looks like sine of A over A is equal to sine of B over B, which is also equal to sine of C over C. Now, this looks tough because there's 3 pieces to it, 2 equal signs. You don't use all of this at once. The formula is just based like this, setting up, because it wants you to understand that, take a look at my picture here, you can use it for any angle. That's why they set it up like this. You really only use 2 pieces of it at a time. It's important to know moving forward that uppercase letters are angles and lowercase letters are sides. That's pretty universal, so it'll be something that you'll be using moving forward. Let me check to make sure we're still rolling here. Good. If I take a look at my example down here, there's one thing that I want to look for every time I start one of these problems, and that's a control. I've talked about a control before, and that's really just terminology that I use. It's an angle and a side that you have that are associated together. If you take a look at my picture, I've got 32, and I've also got 42.9. Those 2 sides are associated because both of those are A's, okay? The uppercase A is 32 degrees, lowercase a is going to be 42.9 centimeters across from it. So that's something that we want to use moving forward. So whatever I set up here, I'm going to use A as my control. Oh, I do not want red. Whatever I do moving forward, I want to use A as my control, so I'm going to put it in there. Now I have to ask myself, what do I want to solve for first, okay? So the important thing to look for moving forward is solve for something that is a piece of information you have, okay? So you have angle B. So the easy thing to solve for would be side B, which would be housed over here, straight across from angle B. So I'm going to set this up for B moving forward. Now at this point I can plug in all the information I have. It's important that you plug in 3 of the spots and leave 1 open, so that's something to solve for. So I'm going to plug in 32 for big A. I actually have little a. I don't know why I wrote A. Little a is 42.9. I have big B. That would be sine of 81.8. And then I am solving for little b, which is over there. If I cross multiply, so you all are always willy-nilly wanting to cross multiply. And most times it's not the right thing to do. Here it is. Okay, so we want to cross multiply. It happens when you have a fraction is equal to a fraction. That's when you're allowed to. So 32 gets multiplied by, sine of 32 gets multiplied by b. So that's really just b sine of 32. I've also got 42.9 multiplied by sine 81.8. That's a number. That right side is a number. I could type that in if I really wanted to, but I would lose the validity of that number because I would have to round at some point. So let's hold off on that to the end. Also, I know most of you don't have calculators. A few of you took it because you were taking the SAT, so more power to you. Feel free to use it. Those of you who don't, just get on Google. There's all kinds of trig calculators, or at least something that can give you a representation of what a sine of an angle is. Also, you can do it on your phone if you turn it sideways, if you know what to do. So at this point, I want to just get b by itself. B is still associated with sine of 32, which needs to leave. So I'm going to divide by sine of 32. It's going to go over to the other side. That's going to make it gone. Now I've got b. Now at this point, I can type all of it in, and it's going to give me a number. So 42.9 times the sine of 81.8 divided by sine of 32. That gave me 80.12. Okay, now I need to look at my rounding over here. On the picture, side A is 42.9. That's rounded to 1 decimal place, so I'm going to round my number to 1 decimal place. Remember, I had 80.12, so I'm going to round that to 80.1. Okay, so that is my B. So I'm going to come over here on my picture and put it in. 80.1 centimeters. Okay. Now at this point, I've got 2 pieces of information left. I need to find angle C, and I also need to find side C. So I need one of those pieces of information in order to solve for the other one, because I can't solve for 2 things at once. The easy thing here for us to do is recognize that there's 180 degrees in this triangle. So if I take 180 and subtract 32 and then subtract 81.8, that's going to give me 66.2, which is angle C. All right, so listen to me about some of your problems moving forward. You might not be given a control, but you will be given 2 angles. So always an easy thing to do to get the third angle is to do 180 minus the other 2. So recognize that moving forward. You may not have a control given in the problem, but just subtract the angles from 180, and that gives you all 3 angles, and then just associate it with whatever side length you do have. That would be your control. Okay, so that shouldn't be too bad for you. You can figure that out. As a matter of fact, if you really want to, you could find that third side or that third angle before you do anything else. It's completely up to you. So now I'm going to set one of these up for C. I still need a control. So I'm going to use A again because I may have made a mistake when I was finding side B. I don't know if I did or not, especially since I rounded. I probably am going to be off a little bit. So I'm going to use A again just because that's the given information to us. So I've still got sine A over A. This time I'm going for C. So I'm going to say sine C over C. And then I'm going to put the information in that I know. So I've got sine of 32 over 42.9 is equal to sine of 66.2 all over C. Okay, this looks awfully similar to that last one that we had. We just have 66.2 instead of 81.8. That's the glory of this thing. It's really just doing the same thing over to find your third side. How come you couldn't do the Pythagorean theorem to find the third side? Because the Pythagorean theorem is only associated with right triangles. Okay, so we do not have a right triangle here. As you can tell, none of these angles are right. So I'm going to do the same thing here. I'll cross multiply. So I've got C sine of 32 is equal to 42.9 sine of 66.2, and I'll divide by sine of 32. Giving me C. I'm going to have to do a little bit of calculating here. I'll do 42.9 times the sine of 66.2. Then I'll divide by sine of 32, which should output me 74.07, and I'm going to round that to 74.1 based on the rounding of our picture. So I'm going to bring it up here, 74.1 centimeters. Now here's what I've got to ask myself. I've done it all. I've got to make sure I'm right. A triangle has to correspond correctly. So the smallest angle has to be associated with the smallest side. In our picture here, A is the smallest angle, 32. It has to be associated with the smallest side. So straight across your mid has to be the smallest side measure. So I've got 80, 74, and 42. So 42 definitely is the smallest one. So A checks out. Let's check B. Or let's just check the middle one. So the middle angle would be 66 because 32 is the smallest, 81.8 is the biggest, 66.2 would be the middle angle. It has to be associated with the middle side length. All right, so 74.1 is the middle side length because it's between 80, and 42.9. I don't mean in proximity, left to right. I mean on the number line. Okay, so 74 is in the middle. Then finally, the biggest angle has to be associated with the biggest side length. So 81.8 is the biggest angle. 80.1 is the largest side length. So this triangle does check out. Moving forward here in a few days, we're going to have some stuff that may not check out. So that's something that we're going to have to be conscious of. So after you finish your problems, make sure you run back through and check this. Okay. So all of your problems that you're going to be given today are going to have, let me zoom this out to where you can see all of it if you need to screenshot this or anything. So all of your problems that you're going to have today are going to be, oh, that's way too far. You're going to be given 2 angles and a side length, just like the example. And then as we go through this in the next few days, we're going to be changing stuff up. So just use this same practice. Find a control. Like I said, you may have to do some subtracting from 180 to find the third angle if it doesn't line up or something like that. Find a control and then pick a spot that you want to solve for, okay? So figure out whether you want to solve for B or whether you want to solve for C. And the way that you do that is based off of the information that you have. If you have both angles, just choose which one you want to do first because you're doing the same process twice anyway, so you can do it whatever order you want. So today we're going to be working on page 301. Let me write this in a different color. You're going to do for me 11 through 16. So I'm not going to try and kill you here. I'm not going to put a ton of work onto you. We're just practicing this, seeing if we can get it, and that's the way it'll be. So do these on your paper, and then, like I said, like I showed you the other day, how to turn it in on Monday. So I wouldn't procrastinate and wait till Sunday night to do it, because that may kick you in the butt. But let me know if you have any trouble. You have my iMessage. Just if you have issues, text me or text the group, or use the Teams on Microsoft. So whatever you need. If you got any suggestions for this, how we could make it better, just let me know. I'm definitely open to suggestions because I don't have all the answers. We'll just do our best. Okay, so let me know if you guys need anything. Good luck with it. I'll talk to you tomorrow.